Well, welcome here. It's great to see all of you. First of all, congratulations on sticking it out through the entire conference. All right, so my name is Jon Dueck. I work in Fresno at the County Office of Education. I work in the STEM program there. Bulk of my work is in elementary and primary mathematics, so I was excited to be able to come here and be a part of this and share ideas. Everything I'm going to share with you was taken from other teachers when I was in their classroom. So that is the best part of my job, is being able to network people who can't leave their classroom and share what other people are doing. So I'm able to take information and pass it along between other teachers and be a part of that whole educational system. And I love what I do and having the chance to do that. So as we go along, I'll have little mini conversations with you as we progress. So we're going to start off, though, with something a little bit interactive, and that is looking. Everything's a little more narrow on this PowerPoint, apparently. So, but you have some paper plates in front of you that also have dots. What I'd like you to do is, everyone needs one paper plate with dots on them. So grab your paper plate. Is anybody lacking a paper plate? Which one would you like?
I'll take that.
It's a good choice. I need everyone to stand up, please. So during our hour or so together, I'm going to be going back and forth between being the teacher and just being your friend. If you're offended, that's me being the teacher. This is going to be so easy because you're not 5. You ready? Hold your paper plate as if it's a steering wheel. Drive, 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 drive. Stop. Get in groups of 2 or 3 if you need to, groups of 2, and look at each other with your steering wheels and share with your partner how many dots you have and what color they are. Look at your partner and say, "Thank you, partner." Drive, 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 drive. Stop. Get in groups of 2, 3 if you have to. And share with your partner. It takes longer with little ones, so this isn't a problem at all. Share with your partner how many dots you have and what color they are. Go ahead and do that. How many dots and what color they are. And now I'd like you to share figure out between the two of you who has the most dots. And how do you know that? Who has the most and how do you know? Look at your partner and say, "Thank you." Thank you. And drive, 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 drive. Stop. So, in 2s or 3s again. This time, we're going to go straight to who has the most dots. Talk to your partner and figure out who has the most dots and how do you know? And you have the same?
We have the same name, too.
What? And now who has the least dots? Who has the least dots and how do you know? Look at your partner and say, "Great job, go back to your seat." Take 2 minutes at your tables and talk about what might an activity with these paper plates and dots look like in your classroom or your job, wherever it is you're at. Maybe you're in the classroom, maybe you're outside the classroom. What might this look like in a classroom that you're in if you were to try this with students at whatever age you tend to work with? 2 minutes, have that conversation at your tables. Go ahead. Class, class?
Yes, yes.
Class, class?
Yes, yes.
All right, what I'd like you to do is share with me. Let's hear from 2 or 3 people about where your conversation just went regarding the paper plates with dots. So would someone share out?
I will.
Yes.
A subitizing activity, where you would show the play quickly, and then the children guess just by quickly looking at it again.
Great.
At a glance.
So a subitizing activity, and we're going to talk about that also in a little bit, so thank you. All right, someone else, walking around with paper plates, what might that look like in your classroom? Yes?
I'll just throw it out here. I was talking about behaviors.
Behaviors would are an issue,
What I want to do is just things in the afternoon with bumper cars.
right?
So I was just kind of mentioning that we have to set that out. It's a great activity. You can totally see being able to implement that in the classroom, but we have to put some parameters around.
Well, it's a great thing to point out. So I appreciate you saying the parameters that should be put out, and also that I love the word you said, that we're not playing bumper cars here, right? So this isn't something, you might not do this right after recess. You might do this a little bit earlier on when things are a little bit calmer or quieter. So there's more parameters beyond that also. So I appreciate like what this looks like, how we move in our classroom, what it means when I say drive, drive, drive. I'm not saying speed, speed, speed. But also about the words that we use. We want our students to talk in complete sentences, and so we'll have sentence stems available. I know that I have the most because, I know I have the least because, I have this many dots. So the idea of parameters, built-in expectations goes right along with this. I don't have to do that when you're all adults, but I certainly need to do this when you're 4, right? Sometimes when you're 15, also I need to put in those parameters. So I did this with a number of teachers, and I went into one of their classrooms soon afterwards, and she had taken paper plates, and instead of dots, she had printed out different pictures of base 10 blocks. So she was a first grade teacher, and there were units and tens in various amounts on each plate. So she was able to take the idea of dots, which is more of a preschool, TK, kindergarten, and then move that up for first grade where they were recognizing base 10 blocks and who had more or less and what those total amounts were. Did anything happen during this where you weren't sure what your answer was? Did anyone have the same number of dots as their partner? So what did you do when you had the same number of dots?
Well, we couldn't answer your questions about who had more, who had less.
So the answer becomes avoided. However, you had a conversation about like, we have the same. So we can point that out. So mid-activity, you can stop and say, did anyone have the same? Raise your hand if you had more, raise your hand if you had less. If a student or students would not raise their hand, that's more that you can add to that. On a side note, you may have noticed that some of these had stickers and some had John made ink marks on them. Don't do that. Just get the stickers, right? So that's why they all went over to this. Some of you had plates that had more than one color. That's an accident, and they shouldn't have gone out. So now you know about the mistakes that I learned along the way. So we're going to keep talking about these numbers and how those interactions look. And the bulk of what we do is going to be for 10 and under with the examples we use, but easily generalized into the upper grades because we are going to get into what it would look like up through third grade and what that looks like. But a couple of books I'll point out, and then we can reference them. One of them is this book called Rustle the Sheep. This is a great book. First of all, it goes from 1 to 10, and it's just got really fun illustrations because you want a book that your kids would like, but that you would also not mind looking at and laughing a little bit as you read it. So Rustle the Sheep, I'll give you the synopsis. I'm going to give you the ending. He can't sleep, and he tries counting stars. He tries counting a lot of different things. And finally, he falls asleep when he counts the other sheep. So cute book when it comes to that. And the more common and popular book is this one called 10 Little Fish. So this might be out there a little bit more, but this also goes up to 10. So it's a nice beginning counting book. And then one final book I'll point out to that goes to, I believe, 26 is the Icky Bug Counting Book. And Jerry Pallotta has put quite a few books out there that have great graphics, wonderful drawings in them. But what's unique about this book, the Icky Bug Counting Book, is that it starts with a number that we tend to not count, and that's 0. 0 is not a counting number, and so we would use this book in reference of what 0 is for our students, which isn't a hard concept for our kids, and we don't say 0, 1, 2, 3. We say 1, 2, 3 as we count. So this is a nice book, though, to have on the side as a sample of something that starts with 0. So just a few books that we can kind of come back to how those relate to what we're doing. It was referenced earlier, the idea of using these paper plates as a subitizing activity, and we're going to talk about that right now. I'm going to put some dots up here, and what I'd like you to do is make a fist right here under your chin. And when you know how many dots there are, put up your thumb. All right? All right. Can I pick on you? How many dots are there? 6. How do you know?
Just by looking at them.
Just by, you can say that. That's fair. Just by looking at them. So you could see that there are 6. All right? Someone else. How many are there and how did you know? Yes?
There's 6 because there's 3 and 3.
She says there's 6 because there's 3 and 3. Which 3 and 3?
The top 3 and the bottom 3.
So you see this 3 and this 3, right? All right. Someone else. I know there are 6 because. Who can answer that question?
4 and 2.
You see 4 and 2. Which 4 and which 2?
4 on the left, the 2 on the right.
Ah. 4 on the left, 2 on the right. One more person. I know there are 6 because. They just get harder, guys. This is the easy one. I heard 2, 2, and 2. All right, so I'll go through. We're going to see some samples of what you've already heard from people as we reiterate this and talk about that. So we can see 2, 2, and 2. We can see that 6 is 3 and 3. Some people say 6 is this 3 and this 3, which is why I asked you to clarify which 3. With what that looks like. So how about this? How many are here? Oh, wait, let me back it up. Let's make this better. Make it better. Make a fist. When you know how many there are, put up your thumb. If you find more than one way, this would be like, I know 1 way, I know 2 ways, I know 3 ways. We're good? All right. And put up more fingers if you can see more than 1 way to do that. Class, yell out how many dots there are. 9. Talk with your neighbors about how you know it is 9. Talk to your neighbors. How do you know it's 9? Let me get your attention back up here. Who's willing to share out one way that they knew that it was 9? Yeah. And we'll talk about that. How else do we know that it's 9?
Well, you automatically see, I automatically saw 4 and 4, and you're like, that's cute, and then there's this extra one on the side.
Which 4 and which 4?
The top 4, the bottom 4, and then there's that extra one.
All right, and I'm going to be repetitive because we're being recorded so the people that aren't here can listen, so don't think I'm weird. So you said you saw 4 and 4 plus the one on this side, then you clarified the row on top of 4 and the bottom row of 4 and the one on this side. All right, someone else.
6 and 3.
Which 6 and which 3?
6 on the left, 3 on the right.
Nice. 6 on the left, 3 on the right. Anyone else see that? So there's 2 questions I'm asking. How many dots? How do you know? And that's all we need to ask. What do you see? How do you know? We don't need to push any further than that. How else can we see that? What else?
Well, I saw 4 and 4 too, but I saw the 4 square and the 4 square and the 1 low.
All right. And if you were in a preschool classroom, it would be at this level, and I could point to each one, right? We could clarify what you're saying, or you could come up here and show me what you're saying. But up on the big screen, you can say, I see the 4 square, and the 1, and as adults, we know that.
You could also do 3 groups of 3.
3 groups of 3. What would that look like? Can you clarify?
The 2 on top, 1 on the bottom, and then the 3 on the other side, so there's a triangle, and then there's like 3 triangles.
Nice. So she sees 3 triangles made out of 3 circles each. You can visualize that however you want to, because I saw her hands. All right. So we can see it like this. We got this. We have many more. Skip that one. We have this one. But the point is, I never said, and that's it, right? And there are no more, right? There's as many as we want them to be as we can come up with. We don't stop our kids from seeing that. We keep saying, how many more? What else can you see? Who saw it different? Who saw it different? Until they're exhausted. And then we don't even say, that must be it. We say, well, we'll see if there's more another time as we go on. All right. There's 2 prompts right there. How could you use this with your kiddos and what math is being done? So talk about what these dot talks might look like for you and what math is happening here. Take a minute or 2 and have that conversation at your tables. All right, let's come back together. Let's hear from one or two people about how this might look with your students and what math is done here. Either prompt, one or two people to share out.
We kind of saw it all. You're counting, you're doing geometry, because it was like squares or triangles, you're noticing patterns, you're practicing multiplying and division, because you're living groups. How many groups of two do we have? You're kind of doing that, but you're also going to divide up the dots into groups.
Let me stop you just so I can get it back on here. So you're the counting, the adding, the multiplying, the dividing, the shapes. Subitizing. Subitizing, seeing that. So humans can subitize to about 8. So once we get to 9, we don't really see 9. We break it apart somehow. Most of us would see at least 8 and 1. At the very least, we would see that. Maybe 4, 4, and 1, breaking that apart as we go along. So you mentioned something earlier about showing something for a very short time. So we're going to talk about that for a little bit right now, because I didn't have that opportunity with how I set this up. But I'm going to show you some dots now. Let me step back. Many of you, if not all of you, have already heard about what a number talk is, and to talk about numbers with your kids. So this is under that realm of number talks, and this would be called a dot talk as you do this. So if you haven't tried doing dot talks, we'll do dot talks with down to our preschool kiddos and working with those. So here's what a dot talk can look like. I'll just facilitate that as if you are really well-behaved 4-year-olds, 5-year-olds, like that. All right. Ready? When you know how many dots there are, I want you to put up your thumb. So you have a fist, and I'll tell kids like on your chest or under your chin to talk about proximity. And when you know how many dots there are, just pop up your thumb. One time, 2 years ago, in Coalinga, I was in a TK classroom and I told the kids, when you know how many dots there are, just up your thumb. And guess what every kid did? Every time. And I was like, oh, I thought I'd be cute and fun, be the cool guy, but nope, never again. All right. So when you know how many there are, just quietly put your thumb up. If you can see more than one way, like this. Here we go. Ready? All right. How many dots were there? 3. And how did you know?
Just visually.
Sure, you just saw it? That's a legit answer for 3. Does anyone have a different answer?
I saw a triangle.
Ah, all right. So let's verify this. So I could ask a student, like, do you think there's 3 here also, like she said?
Yes.
You do. You agree with her. How do you know? Let's count them. Would you touch each one and do that? Right, so we can talk about a little bit of one-to-one with that student right there. So there are 3, we've proven that. And you just saw that there were 3, because as a human, you can subitize that. You can see that there's a triangle. You come with the knowledge that a triangle has 3 sides and 3 corners. Did anyone see 1 and 2? This one doesn't give itself as easily to, well, we had 2 and 1 like that. But let's go a little bit more because you're adults. Here we go. All right. Right? All right. How many dots did someone say? Will anyone share how many dots they saw? In the back. 6. You saw 6? If you agree with her, say, I agree.
I agree.
All right. Well, I heard a lot of I agree, so let's see this right here. I'll give you a chance to look at it for longer. Are there 6?
Yes.
Yeah, and way in the back. So how did you know that there were 6?
4 and 2.
All right, and I could see her hands go 4 and 2 like this. And I'm going to guess, as a teacher, that this means you saw these 4 in a column and these 2 in a column. And 6 can be broken into 4 and 2, or I could say 4 and 2 is 6. So great. Anyone see it differently?
I saw it differently. I saw 2 and 4.
2 and 4, right. So we talked about the commutative property right there. And if you are in birth to 8, the word commutative property is not important, but it's an easy thing to give to our kids when they're ready for that. So the idea that it can be 2 and 4 or 4 and 2 and they both make 6 is an easy concept for our kids to get when they're ready for it. And then to give it a name is not important. But if they're ready for it, give them that name, because they're going to need to learn that. And is that super important at that age? The concept is, but it's really important as they get into the higher math, that commutative property. Does it matter which order you add in? Here's one situation where it might matter. So when we're talking about If I have 4 cats and you give me 2 cats, I'm not really thrilled about that, but I can do it. If I have 2 cats and you give me 4 cats, I'm less thrilled, but I can survive. If I have 99 cats and you give me 1 more, I wouldn't even notice. But if I have 1 cat and you give me 99, that's going to be something to talk about, friend, right? So the way that the order that we add things in isn't important when we're just talking about theory, but when we get down to the story of what's happening, and all of a sudden it's really important right there, right? Yeah, like I can only handle so many cats. So when we show these numbers, when we do a dot talk like this, I'm going to just show it for sometimes not even a full second, right? I'm going to flash it up there and put it back down, because what I don't want is this, right? And then you put it down and they're like, oh, now I don't even know. I'll never know, right? Like the secret's over. So we want our kids to start subitizing, to start recognizing, and we force that by showing it for a very short time. And the students that are in the count each one mode are thwarted in doing that, because we need them to start subitizing and recognizing that amount. And we'll see, you know who the kids are whose parents play games with them because they roll dice. And they can see that right away. And they start to subitize. That's only going to be like 10% of your kiddos. So if you're playing games, if you have dice, random number generators in your classroom, you can do that also. Yes?
So in the world of learning trajectories, subitizing is where in that continuum of learning?
Sure. So the question is, in terms of trajectory, like where does subitizing fit into there? I have an activity right now that we're going to do. So how about this? There's a book that I'm going to put up on the screen called oh, no, we're not going to, how about this? We're going to address that in a little bit. I lost my place, I'm sorry. How about, that's a great question that I am going to address after we talk about this. So we're going to talk now about how this looks in terms of like a 5 frame or a 10 frame. So if I put some dots up there, this is a 5 frame, and if you're a 1st and 2nd grade teacher, you might have never seen a 5 frame, because we tend to reserve these for preschool, kindergarten level. So here, how many dots are there? Tell your neighbor how many dots you see. And tell them how you know it's 3. And who's willing to show? I mean, I realize that you're not children. How do you know that it's 3? Someone raise your hand and tell me how do you know it's 3? This is really the easiest problem I'm giving you today. Yes?
Because the 2 empty squares don't have anything in it, and it's a 5 frame, so there's 5, you take the 2 back 3.
All right, if that was a 4-year-old, we'd be floored and super excited right now, right? Because her answer, she said, because there's 2 empty spaces and
Your hand has 5.
if I has 5, okay, your hand has 5.
Take 2 away.
Take 2 away, 3. So if I had a student solve that by subtraction, I'd be like, whoop, whoop, like, where's the news reporter now, right? Like, let's do this. So we can say because I counted the 3, or we do it by subtraction, either way. But I don't know a better way to say it except that this is a frame of reference, right? We put the 10 frame up there so the kids can recognize what 5 is and what makes 5 when they do that. So as we go through here and talk about the different amounts in the 5 frame, we fill it up at some point, so we get that 1 to 1 again as we do that. But then we can also move to the 10 frame, another frame of reference that I know that there are 10, so that when this shows up, we have students that will solve this by counting. They'll say, I see that there are 3, or I see there's 1 and 2. And sometimes it's, you have to watch my hands, 1 and 2. Sometimes it's 2 and 1. And sometimes it's 2 and 1, right? I would have these in a classroom lower where the kids can come up and touch them, circle them on a whiteboard, or maybe that's on a piece of paper that we can have a few copies of where the kids can circle what they see and do that. And every now and then you'll get the student that says, I know that 10 minus 7 is 3, right? That's an exciting thing to have happen right there. So it gives our kids that place to show the math and talk about what those are. So now, let's talk about where this fits along with what the kids are doing. So you have, this is, how about this? I love to read. Like, I love to read. I love to read so much, my wife gets a little crazy sometimes because I sit there and read and I ignore everybody. I love to read fiction, Professional reading books drive me crazy. I don't like it. I call them all the self-help books that my wife likes to read. And so I try and get through at least one chapter of every self-help book or of every professional reading, but I want to get better at what I do. But this is one that kept me, I think I read at least 2/3 of this book. I persevered through because I really enjoyed it. But he talks about the different stepping stones that our kids go through, especially when it comes to number sense. And this is a great book on how kids learn math because it applies to what we do in here. This isn't about how people learn math at the college level. It's how people learn math when they're 1, 2, 3, 4, and 5 right there. So I recommend this book. It's probably been out for 7 or 8 years at this point. But you have at your tables, really fancy, these paper-clipped packets right there. And what I want you to do is look at what the 5 stepping stones are that David Souza says our kids learn at. This is for preschool and sooner level. So take these, and I want you to work as a team to put them in order, and then we'll have a conversation about that. So unclip them, work in 2s or 3s, put them in order, and then we'll talk about that. All right, some of you are ready to go. Some of you just want me to move ahead because you want the answers. But my screen went black, so there we go. All right, here we go. You ready? Number 1. Children have not yet developed number sense beyond the innate notion of numerosity. They have no sense of relative quantity and may not know the difference between less than, more than, fewer, or greater. So this is, I hope you all got this one because they don't know anything, right? They know that an older sibling has more and that bothers them, right? If the older sibling has less, they don't even care. All right, so just basic numerosity there. So number 2. Children are starting to acquire number sense. They can understand terms such as lots of, 6, 9, begin to understand the concept of less than, more than. They also understand lesser or greater amounts, but not to have basic computational skills. So one of the key things, not having the computational skills yet, right? They've got just baseline pieces coming into here. Number 3, children fully understand less than, more than. They have a concept of computation and may use their fingers or objects to apply the counting up from 1 strategy to solve problems. Errors occur when children are calculating numbers higher than 5 because this requires using the fingers on both hands. I didn't catch that, obviously. All right, so are you really recognizing how much more than, less than is important for our kids at the beginning? Right? That they can see that is more, that is less, without counting, just seeing which is more, which is less. That can happen with blocks, with unifix cubes, when you make towers, which tower is higher, which tower has more. Kind of with piles, some piles are harder to tell the difference between greater than or less than. So we use grossly different numbers to begin with our kids as we do that and become more refined as they can handle more refinement in that. Errors occur when children are calculating numbers higher than 5 because this requires the fingers on both hands. And we'll talk in a little bit about how we have a base 10 counting system because we have 10 fingers. That is why. Why is 10 so important? Because of how we were made with 10 fingers to do this. So we start with the 5 frame because that 1 has important because this is how I'm counting, right? I need one hand to count and one hand to count with as we do that. So that's our 5. Then we move on to 10 with that. So
5 8s have 20?
Say it again. Oh, to 20. Well, you can go to 20, I suppose. Depends on the school. Right? All right. So is Subitizing coming in right now? It might with 1 or 2 or up to 5 perhaps. So there's a little bit of Subitizing that comes in now. And so this is not becoming age specific, but just ability specific. This is a stepping stone that Subitizing comes in after or alongside more than, less than, greater than, fewer. Okay? Number 4, which will give you number 5. They're now relying on the count up or count on process instead of count all. Is that, who's preschool? Where are my preschool teachers? Don't you just does your heart jump when a kid stops, when they can count on, right? When they don't do the count all, you're just right? Like I did it. Yes.
I have a question, because I think most of the times I always question myself. This is me, I'm telling them to have the order, because when they start counting, and I think, because it's confusing, they're counting all, and I am coming as an adult, say, let's go put it in the order, then it's easy to count. And then a lot of times, when I'm reflecting to myself, I say, maybe it's not right, because I am telling to do some things I should not tell it. Maybe they have to figure out if it's in the order that's right. Is make it, I do it automatically. I think a lot of times because I don't want to struggle because there's too many.
Sure.
Yeah, but I don't really know it is right or wrong.
So let me make sure I heard you right. You're saying that you want the students to put them in order so that instead of having kind of jumbled objects to count, they can put them in a row, in a line.
For maybe most preschool teachers, they know we have those small bears.
Yes.
And then if you put the all square, how many bears do you have? Or they start counting, and then they're counting all of them, and a lot of times they just go 1, 2, 3, 4, they go on and on, and they're not really pointing. And if they point it because they're all together, it's harder. This is
right.
my opinion. And then I'm coming to, as an adult, say, let's go put it in the row, and it's true, when I put it in one line, then it's much easier. And then this morning, I watched the video, and it was very interesting. That child, 3 years old, a lot of my kids did the same things there, because I think as an adult, I teach them, put them in one row, then it's easy to count. And I'm questioning,
that's great.
Is this right or wrong?
So the question is, if you give students something to count, do you want to tell them to put it in order, to put it in a line, or how rigorous is this going to be for our students is what that comes down to. And we want it to be rigorous, but we also want it to be something that they can achieve at some level, right? And that's a gray area that there's a whole conversation to have. So because the issue that you mentioned is that when we ask students to count, let's say there's 7 of them, what do you teach?
3 to 5.
3 to 5. So let's say you have 7 bears, and the student would count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Doesn't matter how many there are, right? They stop, they overcount. We have that issue with a lot of our students. So we want them to organize them in some way. So putting them in a row, putting them on a 10 frame, having those tools available is a great method for doing that. Now, if we tell them to use it, that's nothing horrible that you're doing to your kids. In an ideal world, we say, maybe we could organize that, and they come up with a way to organize it. And not every kid does that, right? We want them all to, but not every student does. So if we hint or we offer tools, maybe we could organize it. How could we organize it? It's asking questions that aren't closed, like, do you want to organize it on a 10 frame? Is very different from saying, how could we organize this? Could we use some dots or a 10 frame or this to organize that? What's your preferred way? And so depending on you got a whole group, you have small group, and you have one-on-one. And that dictates what kind of flexibility you have with how open your questions can be. So to offer them a way to organize it is totally appropriate. And there are also times to be more open with what that looks like.
Because I see even right now with the dots, all the time you go in order. That's why even as adults, we are catching it. Even though we have it probably different, we put it in different order, but still they are all in one row, horizontal or vertical, but then they are in order, and that's why we're catching it. That's why it's so easy to just get.
Yes, and I was just looking, so when you do like a dot talk with your students, sometimes your dots are in a nice row or they're in some kind of, every dot paper I showed you was pretty, right? Like everything was like clean lines, but you can also do them where they're just kind of around on there. Like that, thank you. I knew there was at least one plate that was messy. So that's appropriate for our kiddos to have it not clean and neat.
Yeah, because I would have said, is this 3? Is this 3? This one's so far away. Does it still count?
Which is a whole conversation, right? That's a great conversation with 3, 4, and 5-year-olds right there.
Yeah, it's on the plate and it's a dot.
Yeah, addition with that.
One of the quick assessments is have them to line up and start counting them off. And the first person will go, I'm 3, I'm not.
Right? See, you can't always tell these stories when you don't teach preschool, right? Like you do some great stories about your kiddos. All right. I got to keep moving here. So, and then the last one, this one, where they can demonstrate retrieval strategies for solving problems. Automated. This is not automaticity. It's not that they have it in a snap, but that they are able to figure this out at a more automatic level with what they're doing, and then they're gaining the subtraction facts. So dot talks, number talks are really much more about addition. Subtraction comes later on when the concepts are firm with what they're doing. All right, so we're gonna sing this song. You guys know this song?
Yes.
If you don't know the song, hey, I've got the words for you. So I'm going to sing the song with a microphone under me, which I've never done. So, all right, you ready? Here we go. 5 green and speckled frogs sat on a speckled log, eating some most delicious bugs. Yum, yum. One jumped into the pool where it was nice and cool. Then there were 4 green speckled frogs. Glub, glub. All right. What math is in this song? Talk about it at your tables. What math is in this song? Have that conversation. On a side note, because this is being streamed, I stole this picture online for one-time use. Do not ever use this and try and make money off of it. All right. So, you had a conversation. It's going to go like this. If I was working with young children talking about the 5 green speckled frog song, I would have a picture mat that had a pond on it, and it would have a log on it, and each student would have 5 little plastic frogs that sat on that log, and we would say, how many frogs are on the log? 5. And how many are in the pond?
1.
To start, before we start singing, there's 0. So 5 is 5 and 0. And we would sing the song, and as we sang the song, 1 frog would move off the log into the pond. And then I could say, are there still 5 frogs altogether? Have any frogs been removed from the paper? That's a big question right there, right? Because some kids aren't sure that there's still 5 frogs. Some kids know that there are still 5. Some kids are going to have to recount them. And then we can say, now let's talk about our 5 frogs. How many are on the log after you sing it one time? 1 jumps into the pond. 4. How many in the pond? 1. I told you the math would get harder, right? I said it. All right. So now we can keep going, and as we sing the song, we'd end up with 3 and 2. 5 is 2 and 3. 5 is 1 and 4. 5 is 0 and 5. So do you see the pattern that happens right here? Descending order, ascending order as we do this. And we want our students to be able to recognize what's going on here. When our standards first came out, so I'm from the Fresno area, from the Central Valley, fruit basket of the United States, fruit basket of the world right there. So it's peach and nectarine time. It's actually an amazing time and great and very hot time to live where I do. But conservative area, and so our current standards, which we now call the California standards, no controversy there, but you say Common Core standards, and right, like end of the world. And so every now and then I get a friend who'd be like, John, like Common Core, like I hear they're really bad. And I'd say, what have you heard? That they're bad, right? Not educators, they don't know, they just like what they've heard and talk. And I'm like, well, I go, you know what, they're not too bad. Like I think we're gonna survive this one. And they'd say, well, I hear things like 2 and 2 isn't 4 anymore. And I'd be like, well, that's silly, right? We all know that 2 and 2 is 4. But then I'd say this, I go, you know what, here's the difference. I go, 2 and 2 is still 4, but let's flip that. And I'd say, what makes 4? And they go like 2 and 2. And I'd be like, yeah, you're right. 4 is 2 and 2. What else? And they'd say, well, 3 and 1 is a typical answer. I'm like, right, what else? 1 and 3, yeah, what else? I guess 0 and 4, yeah, what else? 4 and 0. I go, yeah, what else? And they're like, that's it. I go, what about 2 and 1 and 1? Well, yeah, of course. And I go, what else, right? I go, well, if you're that, 1 and 1 and 1 and 1. I'm like, yeah, you're great. But I'd say, here's the point, that it's not just about memorizing that 2 plus 2 is 4, it's about what makes 4. So when we have a conversation like this with our kids, we're getting some depth here. So with our littlest ones, we're saying 5 is 5 and 0. 5 is 4 and 1. It is not that the word equals and the word plus are secret words we don't want them to know. We do want them to know that. We can use those. When we say words like is And what we're doing is we're making this more conceptual for it is the same amount. So what you can say to kids when they're ready for it, or what I say to adults, is that we need our kids to recognize that this equal sign is a fulcrum, like a teeter-totter, too dangerous in California for our kids, but a seesaw that balances what that looks like. So like it's a scale where what is here is the same as what's over here. What's here is the same as what's here. And that's what you can be doing no matter what grade you teach for your kids to set them up well for those upper grades. Because at some point, they're going to be doing linear equations where they have to understand what y equals. All of a sudden, they're doing y equals mx plus b, which is literally the same thing that you're setting them up for when they're 4 years old to be successful in algebra. So many times in preschool, the teacher is like, well, I do some math, but we're just kind of counting. Or the world says, well, you're just preschool. What do? Like, you paint for a while? And you're like, I don't paint. That's horrible, right? Anything but paint. And so you're like, no, we do lots of things. But you're doing some major things that are helping these kids be successful in first grade and second grade and third grade so that they are also successful when they get into 7th, 8th, 9th grade when they do that. So I want you to recognize that these conversations about dots and numbers are really huge with what you're doing. All right, with the few minutes that we have left, I'm going to jump ahead a little bit. We just talked about that. We're not going to talk about that. I want you to talk about which do you prefer, 5 plus 4 or 6 plus 7. Have that conversation at your tables. Which one's easier for you, 5 and 4 or 6 and 7? Have that conversation. And why? Which one's easier and why? Who's willing to share which one they prefer? I prefer which one? Which one do you prefer?
4 plus 5.
Why do you, well, who agrees? Who says, if you prefer 4 plus 5, say, I agree. All right, so why do you say that?
I can do it on my hands.
I can do it on my hands. All right. Who else prefers 4 and 5 and can tell us why they prefer 4 and 5? Or is it the same reason? Yes?
It takes less time.
Le-
They just automatically look at it and say, oh, it's 9.
Yeah. I agree with both of you. I think kind of similar thoughts along there. She said because you can almost like see it, right? It's like 4 and 5. And I think I know what's behind that statement, but that's kind of just the basic was like, you can just see it. Just 4 and 5, I know perhaps easier than 6 and 7. We can do 6 and 7. It's not too stressful, but 4 and 5 is less stressful. Okay? I'm not going to I don't have a math degree, so I'm cool with I just like it. So here we go. All right. Who likes 6 plus 7 more? Why do you like 6 plus 7 more? Wait, let me make sure you have any friends. If you agree with her, say, I agree.
I agree.
All right, do you have a couple friends? All right, go ahead.
All right, thanks. Because for me, if I see this 6 as 2 3s, and 7 plus 10 is, or 7 plus 3 is 10, and that's like an easy number to add to. If that makes sense.
All right.
Yeah, I just see it as that.
You see the 6 as 3 and 3, so we decompose the 6. I'm going to make what you said a whole process, which you did like that in a snap, right? But you saw that the 6 can be 3 and 3, and 7 and 3 is 10. We like that, and 3 more is 13. Great, love that. Anyone else prefer 6 and 7? Yes.
I prefer 6 plus 7 because I like 13.
Ah, you just know. I'm like, boom, that's 13. I like that. All right, remember how before I mentioned that we have a base 10 system because we have 10 fingers? And which of these has a sum that is 10 or less? 4 and 5, right? If we do 6 and 7, I don't have enough fingers for that. So I have to start regrouping things. And we tend to not like to regroup. And so that makes it more rigorous at a very child level. This is a more rigorous problem. 6 and 7 isn't hard, but 4 and 5 tends to be easier for most people. But when we go to here, you didn't have to regroup anything. She didn't regroup. You regrouped perhaps, but we're able to just do 6 and 7 like this. We could also do, not like that. We could do 6 and 7, and maybe I could instead decompose the 7, break the 7 apart. I like 10s also, so maybe I'm going to go 4 and 3, and now I have my 10 plus 3 is 13. That's easier for me. I would rather add 10 and 3 than 6 and 7, right?
Well,
Hold on, wait.
I decompose the 7 to a 6 and a 1.
yeah.
Oh,
Because little kids love doubles, because all the time they'll tell me, numbers, 1 and 1 is 2. I go, that's right, 1 and 1 more is 2. And 2 and 2 is 4. I mean, I don't even know if they know what they're saying, but they know it. And 3 and 3 is 6. And I could see one of my higher level kids saying, what's 6 and 7? I said, well, 6 and 6 is 12, and then I didn't do 1, and so it's 13. So
That's
it's like
awesome.
doubles.
So both of you brought up doubles. So if I take my 7 and I can say, it's really close to being doubles. It's not, but it's so close to being doubles. So I can make it 6 and 1. So this would be near doubles. I can make it doubles and then add 1 more. So I'm going to that's 12 and 1 more is 13. Awesome. Awesome. So we want to give our kids, so how about this? If we do this, let's decompose the number 7, and I would just say, what makes 7? I'm going to do it quickly for you, all right? We get 0 and 7, 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1, 7 and 0. We're going to have 1 plus 1 plus 1 plus 1. Like that. Is that enough? Yes. And all the different things in between there. What's happened, if we do this is beginning, then our next step here, I can decompose my 6, or I can decompose my 7 in 2 different ways and use the one that I like the most. So we want our kids to be able to decompose in more than one way. All of these are right. We have 4 methods here. All of them are right, and it doesn't matter which one you use, right? I had a principal ask me on Wednesday, we were talking about the plan for next year. We're going to do a bunch of stuff on routines for reasoning in their classrooms. We're going to be doing everything. This will be a 4 through 12 idea, bringing in some ideas. And then he said, hey, John, before you leave, he says in front of some people, what's your opinion on fluency? I was like, oh, I know what he wants. He wants to talk about math facts. Timed math facts is what he wants. And I had to go into, and I said, well, I can't answer that with a yes or a no. And so I talked about what decomposing was for 2 minutes. And I said, and this is what's important, because this is what we want our kids to go away with. We want them to have those facts memorized. We want them to, I shouldn't say it that way. We want them to know their facts rapidly. But if I had to pick between memorizing and this wins every time, right? So I have a 9-year-old. My youngest is 9. He just finished 3rd grade. And he's the kind of kid, this is wonderful. He gets it from my wife, because I don't think that way. I think in, I memorize what the problems were. I don't go into that. But when he says, Dad, what's 4 times 9? I can respond with, what's 2 times 9? And he goes, okay, then it's 36. Because he knows how to double. He knows that 2 times 9 times 2 is going to get him what 4 times 9 is. And that's where we go when we start with subitizing, with dot talks. How do you know it's 3? Because it's 1 and 2. How do you know it's 7? Because it's 3 and 4. So then when we get to the digits and the numbers up here, this is just a dot talk that's got symbols to it that we're building our kids to. So then when we get to 37 plus 49, nobody wants to do that. But all of a sudden we get the kids that say, well, if I add 1 here, that's 50, that's 87, and now I'll subtract the 1 to make it 86, right?
Yeah.
This is not what many people learned when they were in school. But this is the person that can manipulate numbers and think about them rapidly. I want them to be able to say, that's 16, regroup, and count. 40 plus 30 plus 10 is 80, 86. But I also want them to be able to manipulate them and get what they want with that. Everything that I showed you is on my Padlet, and our time is up. So on this paper at your tables, you can hit this QR code, or you can type in the website, or you can email me. I didn't make enough copies, so I didn't realize the vast number of people that would be here. So if you don't have that at your table, you can get my email address before you leave and contact me. I don't think our email addresses are in the thing. I'll write my email address up here, but if you'd like me to send you something, you can get that. But again, it's all accessible on the Padlet right there. If you wouldn't mind paper clipping those 5 pieces together with the pink sheet. And with that, thank you for coming, and I hope you enjoy the rest of your day.